Have you ever gazed at the night sky and wondered, can we travel to other galaxies in the future? It's a question that has captivated the human mind for generations, a testament to our innate curiosity and boundless imagination. The cosmos, in all its grandeur and mystery, has always beckoned us, inviting us to unravel its secrets and explore its vast expanses. We are, at heart, explorers. From the earliest voyages across uncharted oceans to the first steps on the moon, our history is marked by a relentless pursuit of knowledge and discovery. Today, our quest to understand the universe sees us venturing further into the cosmos than ever before. We live in an exciting era of space exploration. Our spacecraft have visited all the planets in the solar system, from the scorching surface of Mercury to the icy realms of Neptune. Probes like Voyager and New Horizons have pushed the boundaries of human exploration, venturing into the far reaches of our solar system and beyond. We've landed rovers on Mars, discovered thousands of exoplanets, and peered billions of years into the past with our telescopes. With every new discovery, we gain a deeper understanding of our place in the universe and inch closer to answering the question, are we alone? But our ambitions don't stop at the edge of our solar system. The allure of the unknown compels us to look beyond, to the stars and galaxies that fill the night sky. The concept of intergalactic travel, once confined to the realm of science fiction, has become a subject of serious scientific discussion. As we stand on the brink of exploring our solar system, we can't help but wonder what lies beyond. Can we travel to other galaxies? What will we find there? And perhaps the most intriguing question of all, are we prepared for what awaits us in the vast, uncharted expanses of the cosmos? These are the questions that drive us forward, that fuel our dreams of intergalactic travel. And as we gaze upon the night sky, we can't help but imagine the incredible journey that lies ahead. How far have we reached into the cosmos? It's a question that sparks curiosity and wonder. And to answer it, we need to look at our current capabilities and limitations in space travel. In terms of human exploration, we've ventured as far as the moon during the Apollo missions in the late 60s and early 70s. Since then, our astronauts have primarily stayed close to home, working on the International Space Station in low Earth orbit. Our robotic ambassadors, on the other hand, have journeyed much farther. The Voyager spacecraft, for instance, have left our solar system and are now voyaging through the interstellar medium, the space between stars. These spacecraft are still sending back data, more than 4 decades after their launch, but they're moving at a snail's pace compared to the scale of the galaxy. For perspective, if our solar system were the size of a dinner plate, the Milky Way galaxy would be the size of North America. Voyager, traveling at over 35,000 miles per hour, would take about 70,000 years to reach the nearest star. It's clear that if we want to explore other galaxies, we need to think beyond conventional rocketry. The vast distances involved present a monumental challenge. Even traveling at the speed of light, it would take us 2.5 million years to reach Andromeda, our nearest galactic neighbor. And then there are the risks. Space is not a friendly environment. It's filled with radiation that can harm human health, and the vacuum of space itself poses a threat. We also need to consider the psychological impact of such long-duration missions on astronauts. Despite these challenges, we keep pushing the boundaries, propelled by our innate curiosity and our drive to explore the unknown. We've learned so much already, but there's still a universe of knowledge waiting for us out there. Despite our leaps and bounds in technology, our own galaxy remains a vast frontier. It's a frontier that we're just beginning to explore. But with each new discovery, we're getting closer to understanding our place in the cosmos. The universe is vast, but just how vast? Let's try to paint a picture. Picture our solar system, a tiny speck in the grand tapestry of the cosmos. Now imagine a beam of light, zipping along at nearly 200,000 miles per second. Even at this incredible speed, it would take that beam over 4 years to reach even the nearest star to our sun. Now, imagine you're on a spacecraft, traveling at a speed far beyond current capabilities, say 1/10 the speed of light. Even then, it would take you more than 40 years to reach that same star. And remember, that's just the closest one. Our galaxy, the Milky Way, is so expansive that it would take that light beam, traveling at its relentless pace, a staggering 100,000 years to cross from one end to the other. But that's not all. The Milky Way is just one of an estimated 2 trillion galaxies in the observable universe. The Andromeda Galaxy, our closest spiral galaxy neighbor, is over 2.5 million light-years away. That means the light we see from Andromeda today actually started its journey over 2.5 million years ago, when our earliest human ancestors were first appearing on Earth. As you can see, the scale of the cosmos is truly mind-boggling. It's so large that we have to measure distances in light-years, the distance light travels in an entire year, just to make the numbers manageable. And these vast distances pose a monumental challenge for the dream of intergalactic travel. But remember, these distances are not barriers but challenges. Challenges that inspire us, that fuel our imaginations, and drive our scientific endeavors. They remind us of how far we've come and how much farther we have to go. They don't represent impossible obstacles, but exciting frontiers waiting to be explored. The distances we're dealing with are mind-boggling, but that doesn't stop us from dreaming. So, how do we traverse these astronomical distances, you may ask? Well, that's where theoretical propulsion systems come into play. These are the engines of our dreams, the stuff of science fiction that might just become science fact. First up is the concept of a warp drive, a propulsion system that allows a spacecraft to effectively bend space-time. Imagine a sheet of paper. Now, if we want to get from one end to the other, we could walk the distance. But what if we could fold the paper so the two ends meet? That's essentially what a warp drive aims to do. It's like taking a cosmic shortcut. This idea, mind you, isn't just a figment of science fiction. It's rooted in Einstein's theory of general relativity, which allows for the bending of space-time. The challenge, however, is figuring out how to make it work in practice. Next, we have ion drives. This isn't as far-fetched as warp drives, and in fact, it's already in use today. Ion drives work by firing out charged particles or ions to create thrust. It's a bit like how a balloon propels itself when you let it go and the air rushes out. Ion drives are incredibly efficient and can operate for long periods, making them ideal for deep space missions. The downside? They provide very small amounts of thrust, so it takes a while to get going. But once they do, they can reach higher speeds than traditional rocket engines. There are also more speculative technologies like antimatter engines. Antimatter is the mirror image of normal matter, and when the two meet, they annihilate each other, releasing a vast amount of energy. Harnessing this energy for propulsion could, in theory, allow us to reach close to the speed of light. The problem? We're still figuring out how to create and store antimatter safely. It's a bit like trying to hold on to a very, very explosive soap bubble. And let's not forget about the concept of laser-propelled sails. The idea here is to use powerful lasers to push a spacecraft along, much like the wind pushes a sailboat. This method could potentially accelerate a spacecraft to a significant fraction of the speed of light, allowing us to reach distant stars in a human lifetime. While these technologies may seem far-fetched, remember that every reality was once a dream. Today's science fiction could be tomorrow's science fact. After all, it was only a century ago that human flight was considered impossible. Look at how far we've come. So, as we gaze at the stars and dream of intergalactic travel, let's remember to dream big. Because when it comes to exploring the cosmos, the sky is not the limit. It's just the beginning. Intergalactic travel isn't without its challenges. One of the first hurdles we come across is energy. The sheer amount of fuel required to propel a spacecraft to even the nearest galaxy is unimaginable with our current technology. We're talking about quantities that dwarf the entire energy consumption of the Earth for a year, and that's just to get there, never mind the return trip. Then we have to consider time dilation. As we approach the speed of light, time begins to slow down relative to those left behind on Earth. A journey to even the closest galaxy could take tens of thousands of years in Earth time. So, unless we discover a way to travel faster than light, or find a method of suspended animation, any intergalactic explorers would return to an Earth far in the future from when they left, if they return at all. And let's not forget the human element. The effects of long-term space travel on the human body are still not fully understood. We know that extended periods in zero gravity can lead to muscle atrophy and bone loss. Then there's the psychological impact of being confined in a small space for years, possibly decades, with no possibility of return. The isolation, the confinement, the distance from home, all these factors pose significant challenges to the mental health of the explorers. Moreover, there's the issue of cosmic radiation. Outside the protective shield of our planet's magnetic field, cosmic rays, high-energy particles from the depths of space, can wreak havoc on human cells, leading to a higher risk of cancer and other diseases. Current shielding technologies are inadequate for long-term space travel, and developing better ones is a pressing concern.
These challenges may seem insurmountable, but human ingenuity knows no bounds. We've overcome great obstacles in the past, and with the relentless march of technology and science, there's every reason to believe we'll find ways to conquer these challenges too. The road to intergalactic travel is long and arduous, but that's never stopped us before.
What does the future hold for intergalactic travel? Let's take a moment to imagine the possibilities that lie ahead. In our quest to reach distant galaxies, we expect to see some significant advancements in technology. The future of space exploration could be propelled by a synergistic blend of artificial intelligence, robotics, and automation. Artificial intelligence, or AI, could play a pivotal role in enabling intergalactic travel. It's not just about crunching numbers faster. AI has the potential to revolutionize the way we design spacecraft, plan missions, and even how we interact with alien environments. Imagine an AI that can adaptively navigate through the cosmos, making real-time decisions to avoid hazards and optimize the journey. Or an AI that can scan alien atmospheres for signs of life, all while millions of miles away from Earth. Then there's the role of robotics. Robotic explorers have already proven their worth in space exploration, from the Mars rovers to the Voyager probes. As robotics technology advances, we can expect to see more sophisticated machines venturing into the cosmos. These robotic pioneers could be our eyes and ears in distant galaxies, enduring the harsh conditions of space and relaying valuable data back to Earth. And let's not forget about automation. The vast distances involved in intergalactic travel mean that many processes will need to be automated. From onboard systems maintaining the spacecraft to automated laboratories analyzing extraterrestrial samples, the role of automation in future space exploration cannot be overstated. But as fascinating as these technological advancements are, they are just pieces of a much larger puzzle. We're talking about a journey that could span millions of years and trillions of miles. Every innovation, every breakthrough brings us one step closer to that dream. However, we must also remember to temper our excitement with caution. As we push the boundaries of what's possible, we must also consider the potential risks and consequences. After all, space exploration is not just about reaching for the stars, it's about understanding our place in the cosmos and ensuring our survival for generations to come. The technologies of tomorrow may make the impossible possible. As we reach for the stars, we must also consider our responsibilities. The dream of intergalactic travel isn't merely a test of our technological prowess, but also a challenge to our ethical discernment. As we push the boundaries of our knowledge and explore new frontiers, we must ponder over the potential impact on extraterrestrial life. While the existence of life beyond Earth remains a topic of debate, the possibility cannot be negated. If we stumble upon life in other galaxies, how do we interact? What are the guidelines for such encounters? These are questions we need to address before we embark on our cosmic journey. Moreover, the importance of responsible space exploration cannot be overstated. The cosmos is not merely a playground for our exploratory impulses, but a shared resource that demands respect and responsible stewardship. We must ensure that our quest for knowledge doesn't lead to a disregard for the environment, both in space and on Earth. Our actions in space should be guided by the same principles that we uphold on our home planet: respect for life, protection of the environment, and a commitment to peaceful exploration. It's not just about reaching new galaxies, but how we get there and what we do once we arrive. As we venture forth, we must ensure our curiosity doesn't compromise our conscience. Intergalactic travel is a vast and complex subject. It's a captivating journey through human curiosity, engineering ingenuity, and the profound unknowns of our universe. We've delved into our current capabilities, barely scratching the surface of the cosmic ocean, and journeyed through the theoretical propulsion systems that might one day take us beyond our galaxy. We've grappled with the immense scale of the cosmos, a scale so vast it challenges our comprehension. Yet it's this vastness, this challenge, that fuels our collective ambition to explore, to learn, to push the boundaries of the possible. We've considered the hurdles ahead, the technological, scientific, and ethical challenges that come with venturing into the unknown. The energy needs, the impacts of time dilation, the potential effects on human health during prolonged space journeys, and our responsibility towards extraterrestrial life and environments. We've also looked to the future, to the breakthroughs that could revolutionize space travel. the potential roles of artificial intelligence, robotics, and automation in navigating the cosmic expanse, and the importance of responsible exploration. As we wrap up, let's take a moment to marvel at the possibilities and weigh the tremendous challenges of intergalactic travel. What might we discover out there in the infinite expanses of space? What might we learn about ourselves in the process? While we ponder the mysteries of the universe, remember, every small step forward brings us closer to the stars.